Hi, all. Good morning or good evening, depending on where you're located. Thank you for joining our Power BI webinar. And my name is Deepak Shankar. I'm a community manager within the Microsoft Business Application Group. And today we have Mihail, an MVP, who will walk through the new Power BI features and how to build modern solutions with Cosmos and Power BI. So, hi, Mihail. Welcome to our webinar session, and it's all yours now.
Thank you for the introduction. Hello, everyone. I just will say a few more words about myself. I'm Microsoft MVP in two areas, Microsoft Azure and Data Platform, and also member of Microsoft Regional Director Program. I have experience mostly with big solutions related to Azure and IoT, working like solution architect and enterprise architect for big customers, enterprise multi-billion companies usually. Last 10 years, I'm focused on Microsoft Azure, and also last 5 years, I work on solutions tightly related to Internet of Things. This presentation is related mostly to how you can integrate Cosmos DB and Power BI in the context of modern Internet of Things solutions. So we will go through the agenda. We will consider a few things about uh, Internet of Things solutions, best practices, some important things related to reference architecture, some scenarios and recommendations, and after that, we'll go to scenarios where we can use Cosmos DB and Power BI in Internet of Things solutions. And after that, we will go deeper in some patterns where we can integrate Cosmos DB and Power BI. And in the end, we will have few short demos which will represent integration patterns, how we can integrate exactly these awesome products in modern Internet of Things solutions. So that's the plan, actually. What we can have in the beginning. Uh, Probably you know that Internet of Things is real hip in modern software industry. Not only software, but we will be focused mostly on this part. And the number of solutions and connected devices is growing and growing. And we have already billions devices, which will stay several times more in the next years. Internet of Things cover almost all areas from modern industry, including automotive industry, including energy area, including agriculture, logistics, smart cities, healthcare, almost everything. And our devices will stay more and more connected. So actually, this is a huge part of our industry where we can have many challenges. We have almost all parts of modern solutions in Internet of Things in different scenarios. We will talk a little bit about this, and we can have the whole power of services like Cosmos DB and Power BI in the context of these Internet of Things solutions, of course. I will explain few things related to common recommendations because in IoT solutions we have some good practices which we will have in all solutions if we want to have uh, good design and reliable solutions, and there is important specific knowledge related to specific platform, in our context Microsoft Azure. So we actually will talk about all these details in our presentation. About common practices, it is mostly from the architecture part, and it is quite relevant also for other solutions. In the big part of these recommendations, we need to have, if it is possible, simple solutions. That means we will try to reduce the complexity. We have also specific layered architecture here, which is a little bit different than architecture which we consider for other solutions. We will talk a little bit later about this. We need to have security by design anywhere. We need to be very precise related to the data model. We will need to automate all operations related to development of these solutions. Scalability related to fast-growing number of devices and workload is very, very important. Many solutions are with specific requirements related to response time as some other specific metrics, which we will consider. And of course, cloud is one of the main reasons to have such kind of growth of this kind of solutions, Internet of Things. High-level design is actually split to two parts. Part which is on site, that means different sensors or managed objects, and devices which are connected to the backend using internet connections. And we have more or less complex analysis on the backend. IoT back office is the major focus of what we will talk during this webinar. But devices are important because we need to collect all this information from sensors via a specific approach and to ingest this data in our storages which are on the backend. Considering layered architecture in the context of Internet of Things, we have three layers which we consider a little bit different, as I explained, than what we have for other solutions. We have backend, which is mostly cloud related, and we will talk about cloud. We have edge. Edge means everything which we have like processing, filtering, aggregations on site. And we have also additional devices which are in the context of sensors, gateways, and other equipment which we need to have the whole Internet of Things solutions. Very important part is security. Our webinar is not focused on security, but it is important to know that regarding to this part, we need to consider every component in the context to have separate security. Because if one part of our Internet of Things solution can be compromised, there is a huge probability this to lead to compromising of the whole solution. So we need to consider every component as part which need to be secured independently, not only to rely on security which brings the whole solution. Another important thing is related to data model. Now we have very modern approaches for microservices solutions where different microservices will keep their data separately. But in Internet of Things, we have several huge storages, I mean, a amount of data, which can be in many designs, also shared between different services. Just it depends on specific cases, but we have from one side storage which need to collect all data, and we have different storages related to aggregated data which we will have, and configuration data. But from the beginning, it is good to know from where data comes. And in this context, we have data which is generated from devices. We have data which is generated from users who actually manage the system. We have data which is from outside systems. From example, we can import data from hardware supplier related to devices. And we have also additional data which is related to authentication, user identity, and different kind of configuration. About the data model, we can split our storages to several groups. We have raw data storage, which usually collects not processed data. I mean, data can be processed, but will be in a raw state. We will have no specific aggregations, which will be good to be in separate storage. We have metadata storage, which quite often is needed to optimize our traffic. That means our raw data will be enriched with metadata to have collected data more readable during the analysis. We have aggregated data storage, which can be as a result of some real-time or close to real-time processing, and also it can be a result of some additional analysis. And we have configuration data storage, which is quite important to have the whole configuration for our solution. Oop. About raw data storage and the context of Azure, we have different options. Usually we are looking for cheap storage, which can be used for huge amount of data. And it is very important this storage to be scalable. One natural options is when we have Azure Blob Storage, because it is cheap and it is easy to use. But in this context, we have some limitations. Azure Storage cannot support many indexes, so we will have limited search, or we need to have additional services which will be responsible for indexing, which means we will have additional storage for index data, and we will have additional computing also for implementation of this indexing. It is possible regarding to requirements to have also for raw data different kind of databases. Quite often, if we have a good understanding about the amount of data and can optimize the structure of our raw data, we can use a NoSQL database like Cosmos DB, which is fast, supporting different kind of searching and analysis, and providing very good scalability. But it is something which is related to general approach, and it could be considered case by case based on the requirements. It is possible to have also some more complex solutions where we can have time series databases with complex logic, but we need to have case because such kind of solutions usually have higher cost, and we need to have business case to use it. Yeah. About metadata, usually metadata is in such kind of structured format. So quite often we persist metadata in relational database. Azure SQL database is one of the best options for this, but we can consider also document-based solutions like Cosmos DB, which can work also in this context, depending on how our data is structured and depending on how we can manage it for specific purposes. Some of NoSQL databases are also good option for this. Configuration storage is considered in few different cases. From one side, different parts of solution has own configuration, and from another side, we have one very important component of the whole Internet of Things solutions, which is named device configuration management. Usually this part manage all information about provision devices, their state, and additional information related to these devices, where these devices are mounted, organizations which actually owns these devices, and additional related to specific case data. So configuration storage usually is also a SQL database, but we can consider some NoSQL solution, document-based, like Cosmos DB, for specific cases like alternatives. Aggregated data storage usually is a storage where we persist data which we already process and have this data in some aggregated state. This data is used for scheduled reports, reports on demand, or some other analysis. And here usually again we have structure, and again relational database, and some NoSQL databases. Again, Cosmos DB is one good example, can be considered as storage for such kind of data. To summarize, for most of storages, depending on the specific case, Cosmos DB can be considered like option. But again, it is difficult to talk on a very general level when we have specific cases and have more precise analysis. It could be more clear if Cosmos DB will be the best option. Just it is applicable for all these areas. I will not cover all parts of Internet of Things, but it is good to mention several things which are important in the whole design of these solutions. First, we have in Internet of Things something which is quite important. We have network and connectivity cases, because we have distributed systems and we collect our data from remote devices in different locations. That means we have always communication between some devices which send data and services which collect data. What we need to consider is how to implement connection, and regarding to the common understanding, it is good to spend just few minutes to go deep in details. Usually when we have Internet of Things solutions, the weakest part is the part which can be protected more difficult. What we consider in the context of protection, usually we use encrypted connection, but when we have such kind of security, we need computing power to encrypt and decrypt our information. Backend services, especially in the cloud, usually have enough computing power for this. When we talk about devices, sometimes it is possible. We have already quite powerful devices, but sometimes it is more difficult to have the same options like on the backend. So devices usually need to be protected better. Years ago, Internet of Things solutions were considered in the context where devices will not accept inbound connection. They will always initiate connection to the backend. And this approach actually make backend with one potential security hole in the context of the gateway service or the service which accept connection. After several stages of evolution, now we have much better security based on service-assisted communication approach, for which I will say a few words. We have several types of communication between backend and devices. The most straightforward is when we have telemetry. That means we actually receive information from devices and do not send anything. In some cases, backend need to send response based on specific information from devices. So we have inquiries in this case. And we need to have this information finally received in devices. If we have the same approach, but from opposite side, backend to send information and to receive response from devices, such kind of communication we consider as commands. And the last one is related to notification, where actually backend notify devices about some specific things without any need to expect response. Historically, devices are protected with specific firewall. When we have such kind of design, as I already explained, we have more issues in the context of the backend. And this case is solved in the modern solutions when we have so-named service-assisted communication approach. In service-assisted communication approach, we have in the gateway two different queues which actually accept information from devices and from the backend. And we have never direct communication between devices and backend. Devices send information to one queue on the gateway service, in the context of Azure, this gateway service is Azure IoT Hub usually, and backend send information to another queue, which is in this gateway service. Each site writes information to one own queue and reads information from another queue, which is with information from the opposite side of the whole solution. In this case, we have communication, which is very secure, and only the gateway service accepts connections. So even potential attack succeed against gateway service, we will have quite secured other parts of our solution, because there is no case where gateway service actually initiate connection to other services or device. One very important thing in modern cloud design and of course also IoT solutions is that cloud is moving target. That means good practices now can be obsolete after few years. And everything which we consider now will be relevant for few years, but cloud design is approved every year. So new services will be available, and existing services will be extended to work better with more features. So everything which we discuss now will be relevant probably for the next few years, and after that everything is possible. Usually when we work on design on specific cloud solution, we consider the latest features, because when solution is ready with life cycle 1 year or 2 years, for example, these features will be actually on their heap of usage, and there will be a specific period of few years after when this solution will be actual, before to consider for some update based on changes in the cloud platform. One good thing in Microsoft Azure and IoT solutions is that there are very good examples related to the reference architecture. That means we have very good blueprints how to start to design these solutions without to make big mistakes. This approach help architects and developers to start easy and to have a relative good design from the beginning. We have different components, and what will be most important in this webinar is actually how we will put in the whole blueprint our database, Cosmos DB, and Power BI, like BI and reporting tool, which is used for different kind of analysis and visualization. If you see the schema here, actually you can see that we have solution UX, which actually is also related to Power BI, but Power BI also covers part of analysis and logic. From another hand, we have several different storages. I already explained that Cosmos DB can be considered as almost all type of storage in general. What is interesting that usually we need some additional components to connect these services in the whole solution design. All data usually comes through one common channel, and in our case, it is Azure IoT Hub. When we have our Azure IoT Hub, actually it is service which provides messaging functionality, but also provides additional security options to manage devices, options to have multi-tenancy support, options to be configured in different ways, automatically or on demand. We need to have some clue between devices which send data and our storages and analysis services. In this context, we can have different messages services, as already explained. IoT Hub is just partially in this role, but it is actually the most important component in the context of communication as gateway service. Additionally, we can have different messaging services which will be part of our flows, which we will consider a little bit later. Different kind of um, services like service bus, when we need to have more complex logic regarding to messages, if we want to have topics, if we need to add some additional rules for our messages related to multi-tenancy and other things. We have Event Hub for mass spreading of information, but Event Hub actually usually is a service where other services are subscribed and pull data. In some scenarios, we need to have event service which push data, and Event Grid is one very good option for this. Usually, when we consider modern solutions, we are looking for the simplest way how we can implement solutions and to have also optimal usage of resources. In this context, for many scenarios, we are using serverless components. I'm considering here Azure Functions, for example, because usually serverless solutions spend less resources. And if we have options in the context of functional and non-functional requirements, it is recommended to use it in most of solutions. One good thing in the context of Cosmos DB is that you can have several different options to have event-driven design or to actually call functions from Cosmos DB. It is possible to work on lower level using change feed. It is possible also to use triggers which Cosmos DB supports and to call functions from these triggers. Cosmos DB is quite good optimized for event-driven design and fits very well in the context of solutions where we have Azure Functions and we can have lightweight solutions for Internet of Things. Another interesting approach is when we need to have from our solutions actually analysis which are straightforward, but we need to have a specific logic where we need to rise this logic based on specific cases. In these situations, we usually use stream analytics, the most popular service in Azure for stream processing. And we can rise Azure functions from this service directly or to have more complex logic via additional services. For stream processing, you can use, of course, different solutions. You can use open source solutions. You can use Databricks. You can use Apache Storm. But just Azure Stream Analytics is probably the easiest way to start work on such kind of solutions in the context of stream processing. Several scenarios which we can discuss a little bit more detailed in the context of usage of Power BI and Cosmos DB in IoT. If we see this schema, we have the common components which we have in one solution. First, we have devices, as it was mentioned, different IoT devices with edge processing or without edge processing. We have communication via Cloud Gateway or IoT Hub. We have such kind of close to real-time stream processing. And we are able to use Cosmos DB for warm path, that means for processed data, but also we can consider it again for cold storage, that means for raw data, depending on amount of data and when and how we will process this raw data in the future. And about UI reporting and tools, Power BI is one of the most powerful components which we can use. It can be integrated with stream processing, but we can have additional business logic which will be between storages and Power BI to represent some information based on analysis on demand. To be more complete, I will try to add few details about all options which we have for IoT architecture, again with alternative services. If we consider stream injection, you can use different services with these functionalities, which can replace IoT Hub. Just IoT Hub is the most optimized, easier to use, most developed, but you can use Apache Kafka, you can use Event Hub. Most of these services have no functionality for embedded security and functionality to manage in automated way devices via this service, like IoT Hub. So this is probably the most important part which makes IoT Hub so attractive. About stream processing, again, we have many different options in the context of open source, and we are using Azure Stream Analytics because it is easy to use, it is cheap as service, and you can have low costs, and you can have short time to market if you design solutions including Azure Stream Analytics. Azure Stream Analytics quite often is used as glue also between other services. It is not always the best pattern, but because it is possible to make it easy and relative on low cost, you can see many solutions where Azure Stream Analytics is used like output and input for different services, despite that the major reason to have Stream Analytics is to have stream processing. I kindly recommend to avoid this practice and to use serverless solutions like Azure Functions when it is needed, if you need just to make connection between different services. When we consider storages, as I mentioned, Cosmos DB is applicable anywhere. We will not be focused on other options for storages. All these options are interested, but this webinar is focused on Power BI and Cosmos DB. Regarding to presentation and analysis, you can have also very fast and relative cheap, depending on what kind of analysis you are having, how many users you have. But yes, relative optimized solution using Power BI. So it is a very natural solution for analysis and presentations in IoT solutions. If we have need to connect different components, quite often you can use it also with Azure Storage, because Azure Storage also supports option to have subscribing for Azure functions, so you are able to call serverless solutions in this case. Despite that it is a service used mostly for cold path, for raw data, we are able also to use it in some scenarios in the context of the whole integration. It is useful based on the support of events when we actually change our data. And now we will continue with some patterns, how we will be able to integrate our solutions with Cosmos DB and Power BI. One typical solution which was not very easy to implement in the past is when we have in our solution raw storage, we have logic which is raised based on serverless components, and we have processed data in Cosmos DB, and we have output from Cosmos DB to Power BI. Now it is possible because Power BI has Cosmos DB connectors. Cosmos DB connectors are still in preview, but now it is one relative easy way actually to have from one side process data in Cosmos DB and output directly from Cosmos DB to Power BI. If we need to have data which is based on raw data analysis from Azure Storage, that is another case, and we can have different patterns we can make this with serverless components like Azure Functions, or if we have our data with a clear structure, for example, like JSON documents in Azure Storage, it is possible to access it from Power BI for such kind of analysis. We can have the same design with different kind of messaging services in front of. I already explained that IoT Hub is the preferable option, but we can use instead the IoT Hub different messaging services in the context of data storage and analysis and UI. It will be usually the same, at least till the moment when we start to have support for Power BI directly from IoT Hub. For now, it is not possible. Another option is when we need to integrate Cosmos DB or Power BI or both directly with IoT Hub. As I explained, this integration is not possible without additional components for now. We need to have some component in the middle, and Azure Functions is probably the most natural option for this because it is cheap, you can control it, but it requires more or less development. If you have no options for development, it is possible to make it with a service like Stream Analytics. Again, my note is that Stream Analytics is good to be used when we have data processing, not just to connect services, to use it more efficient, of course. And we can have much more complex scenarios where we are able to have our data persist in different services and with several steps actually to receive our data in Power BI. Usually we have such kind of solutions when we need to have on several steps processing and enrichment of our data. It depends on specific use cases which we can have in our solutions. We can use also in the middle different services for processing when we have a real need for processing. Usually these services can have output to HTTP endpoint, which, as we will see, is possible for both for Cosmos DB and for Power BI. We can have also integration between Cosmos DB and Power BI in the context of AI components, because quite often we need to have analysis where to call services published from using cognitive service, Azure Cognitive Services, or if we have Azure Machine Learning models. As you see, we have many different scenarios, but usually the devil is in details. And that's the reason to go a little bit deeper in some patterns on the application level, how we will use actually Power BI and Cosmos DB for these solutions, which specific things we need to have in mind. Regarding to Power BI, one of the most interesting things is when we have real-time data sets, because for static dashboards we will have no something which will be different than what you know about Power BI and other type of analysis and creating of dashboards. But in the context of streaming dashboards, there are specific details, and it is good to have some overview. When we have live data dashboards in Power BI, we can have several options to implement these using several different type of data sets. These data sets actually have small differences related to their behavior, but in general, we consider all these data sets like stream data sets. I will go in some details. We have options when we can push data to Power BI from services like Azure Stream Analytics. And in this case, we will have actually push data sets. Push data sets give us option to have live data, but to keep history. We can use another specific type of data sets, so named streaming data set, where this data set is considered to keep in cache for a specific short timeline data, and after that, this data is not accessible. This data is deleted. We can use API calls to implement these streaming data sets, and we can configure these data sets actually in specific cases, also to keep historical data and to be like push data set. But in general, the context is to have data only for short period of time, and this data is needed to represent actually life changing of some specific metrics, and after that we will have no need to store this data in Power BI dataset. A specific additional feature is so named PubNub dataset. PubNub is a service, software as a service, which can be used to publish data from different devices. It is considered mostly as a service which is used for IoT solutions, but it could be used also for other purposes, for chat, for example. And we can be subscribed from Power BI for such kind of data sets and to display data which comes from such kind of solution. What additionally is important? Streaming data sets which we are using with API need to have some configuration. We will go through these steps during our demos. For push data sets, if you are using, for example, Azure Stream Analytics, it could be done without any knowledge about API configuration. Push dataset, as I mentioned, keeps historical data. And for PubNub, you need to have some knowledge about how to work with this service. If we consider the common streaming datasets architecture, this schema can represent how all these streams work actually. And as you see, all these services, excluding PubNub, actually work with Power BI REST API, but for PubNub it is additional specific SDK which need to be used to manage it. And there are some specific limitations related to different kind of streaming datasets, which you can see here, related to what amount of data you can have, and if it is possible to store data or not. It is part of Microsoft documentation, so you can go deep in details using docsmicrosoft.com, and you also will have access to this slide deck. About API integration, the good thing is that actually you are able to have custom solutions which can be configured in a way to work with API of Power BI and to send live data, and this data to be considered like streaming data set. There are several specific things which we will see. How we will call our Power BI endpoint from Azure Function. It is one of the demos which we will see. We will have a very short demonstration related to this. I already have the whole setup deployed. And we will consider a few things also related to Cosmos DB. As I already explained, Cosmos DB has no direct connector for IoT Hub for now, and we need to have a separate service or custom logic, and its connectors for Power BI are still in preview, but you can use it. You are not able to use Power BI .com site directly. You need to create a project using Power BI desktop, and you can have diagrams based on Cosmos DB. But you are not able to have live diagrams directly from Cosmos DB. You can use live data or data which is changed in Cosmos DB, but you need to have a solution where you will have some logic subscribed to change feed, for example, and to trigger Azure function, which will call Power BI API to fill streaming dataset. These are scenarios which we can have, and now I will try to demonstrate a few demos. For this purpose, I will change the program which I will share. First, I will try to demonstrate example where we have device which sends information to IoT hub using device simulator. It is the same like if we will have a real device. And in this very simple simulator, we are sending actually information about wind speed for specific devices, and we will have additional information about the device ID. We have, in this case, just one device, but we can have many. And IoT Hub and Azure Stream Analytics are able to add additional information like additional metadata. Azure Stream Analytics usually adds to messages information about when specific message is received and when specific message is processed. I will start this simulator and I will show you the output screen. Output screen will start to print actually message information about messages which we are sending. The next component which we need to see is actually our Azure Stream Analytics service, which is in Microsoft Azure. I will try to move to our presentation screen. One Azure Stream Analytics job, which is already created. Here the idea is just to show how we can send information to Power BI. So I did not add it in the query specific logic for processing, but again, the good pattern is if you are using Azure Stream Analytics, this to be when you have a reason to have processing. So this example is mostly to demonstrate what will be the possible approach. We are starting this job. It will take several seconds till job is started, and I will show you after that actually how we have all this information in Power BI. In advanced, we can see the output here. Output can be configured for different services, and it is not possible when we have already running job to manage this, but actually what we are not able to see here are settings for connection, which we need to add when authenticate this job to Power BI. After a few seconds, we will be able to see what we have in Power BI. I will hide this screen and will show you Power BI screen, which actually after few seconds will start to visualize information from our simulated device. in the moment, we see the old information, and this information will start to be changed when our job service actually started and the whole information is received in Power BI. When we have such kind of information, we need to have for a specific workspace dashboard. And if we have dashboard, yes, I think that we started already to have this live data. We can add additional tile with custom streaming data. And if this data is from Azure Stream Analytics, we will be able to have the output already available. We will be able to use different types of representation, several charts, or just a simple card. For example, if it is simple card, we can configure details, and we are able also to create phone view if it is needed. Now for presentation purposes, I will not go to configure this. So we are able to have such kind of solutions using IoT Hub and Azure Stream Analytics, and it works quite easy. Now I will demonstrate how we will be able to have the same approach with Azure Functions. I will demonstrate the projects with Azure Function, which we have. This is a simple project where we have actually one function which is already deployed. I used information which is already available in another service for Bitcoin price. So this pattern is mostly to represent how we can connect with serverless, with Azure Functions, Power BI. I will demonstrate in this case how it is implemented in our Azure deployed function. We are starting the function, and it will take probably a few seconds. And you will be able to start one function which in infinity loop actually sends information about Bitcoin price to Power BI. I'm showing again one live dashboard which is already created with several times which use this price. which is used to visualize price of the Bitcoin using this Azure function. And meanwhile, here is another tile which represent the same approach via PubNub. So this is the most important, which I would like to demonstrate in the context to how I am able to integrate live dashboards in several different ways. We can go in many edge cases, but this webinar is mostly to represent the major functionalities and how we will have Power BI and Cosmos DB as useful components in modern Azure IoT solutions. So thank you very much for the attention, and I will be glad if you have any questions to answer your questions.
Thank you so much, Mihail. And there is no questions for now. Mihail?
Yes,
Yeah.
I'm here. Yes.
All right. So we don't have any questions, and it's been a wonderful webinar session. So do you have any other questions or inputs you need to give? Else we can close the webinar.
Thank you very much for the great opportunity.
Thank you so much.
Have a nice day.